Yeah, good morning, good afternoon, good evening, wherever you are joining us from. And you are welcome to Abbettect Nigeria Limited. This morning we have a little project before us, which is an automated sequence controller. This sequence control is normally used to operate different devices uh, in an industrial plant. We use to operate different devices like motor, equipment in the plant, matching and other equipment that we can think about in the plant. So this system is normally operated using a drive, but due to the cost of the drive, we are making this design to do the same function at which a drive is going to be functioning. This one, the drive is just a variable frequency um, controller. But this one is not going to be converting. It's just the function that we are making use of. We are not converting frequency. We are not converting the power or the voltage. We are not converting anything. But the function at which a drive function, that's what we just want to, that's what we are trying to implement in this system. Before I tell us the function, how this system function, I just want to tell us the little component that we have before us. We have our auxiliary contacts. We have our breaker MCB triple. We have our contactor. We have overload relay. This overload relay is the one that break the signal between the motor and the system when we have a higher current beyond the the required current that is being set on the overload relay. So the overload relay just it serve as a protection to protect the motor from being get burned. Maybe if you have a higher current or that's supposed to damage the motor, this overload relay quickly cut off the supply going to that motor to protect the motor. And we have our indicator lighting. We have our stopper timer. This stopper timer is the one that control the motor A. That is after stopping, it make the motor A to continue running for some period of time before it finally stop. And we have a multi-purpose uh, timer. This one is the one that is attached with motor B to dictate to motor B on how to operate, on when to delay, because we have a delay time and we have a running time. So it's the one that dictates to motor B your running time and your delay time. We have a normal relay. This one is just 10 amp 250 volt normal relay. We have a control breaker here. We have a selecting switch here, on and off. We have selecting switch. We have a push button, go stop and start, and push with light. And we have indicator lighting and other components in the system. So I'm going to be telling us how the system operates. The interlog of this system is defined as if motor A is not running, motor B will never come up. If you did not start motor A, if motor A is not running, motor B will never stop, will never start. If you start motor A and it's running, that's when motor B can start. That's when you can start motor B and it will respond to your calling. And when motor B is running, this multi-purpose timer that's attached to motor B will be the one to dictate to motor B on when to run and when to stop, as I said earlier. And this stopper timer is the one that dictates to motor A on when to stop after stopping the motor. If you tell the motor, don't stop now until the time that we have set on you reach. So motor B will not stop. When you stop the system, motor A will not stop until the stopper timer that it has been set has gotten to the level of that timer before it will now stop. So I'm going to on the system now. I'm going to operate the system now. You're going to see how it functions, how it works, so that you can have a clue of on how the system operates. And one more thing, immediately you energize your system because of the stopper timer that is attached with motor A. Motor A will immediately start running for that same period of time. Let's say like 10 seconds that you have set. It will start running for 10 seconds before it now be on a ready mode. That's the that's the interlock. That's the program. When you power your system, immediately, even without starting the system, immediately you put power to the system, and the system detect that there is power in the system. Motor A will start running immediately for like 10 to 20 seconds before be on a ready mode. After running for 10 seconds or 20 seconds, then it will now stop. Then it will now be on a ready mode for operation, ready for operation. So I'm going to on the control breaker here. Then motor A will come up. After that, it will be on a ready mode. So yes, you see now, motor A is running now. It's running now. Now it's on ready mode now. This is how it operates. This is how it operates. Now the system is ready to be operated. And as I said earlier, this the switch for motor B. This selecting switch. If I on motor B now, it can never start. See, it can't start. You see? Because motor A is not running. Did you get it? So until this switch is to start motor A and this to stop motor A. This to start motor A and this to stop motor A. And if I start motor A, then I can start motor B. So let me start motor A now. Now motor A is running now. Did you see that motor A is running? And this is the indicator light to show that motor A is running. And this is the motor. Let's assume this is the motor has been energized. You understand? So motor A is running. Now if you want to on motor B now can now respond to your calling. So let us on motor B. This is a switch to control to on motor B. Now I on motor B. You see now. You know that I told you that this multipurpose timer is the one that dictates to motor B on when to run and when to stop. Is a delay time. You give a delay time when to run and when to stop. That was the reason why immediately I on the system, I on motor B. The motor B did not close immediately. It waited for the time to dictate to the motor when to close. Did you get it? So now, if I should stop motor A now, motor B will automatically stop. You understand? I'm going to stop the system because if I should stop motor A, motor B will stop because the program says if motor A is not running, motor B will never run. So if I stop motor A now, motor B will automatically stop. But motor A himself will not stop immediately. It will wait for this stopper timer to dictate to this motor when to stop. So let me stop motor A now. Now I stop motor A now. Motor B have stopped immediately. But the stopper timer have taken over. Now it has stopped finally. Do you get the system now? So if I want to increase the stopper timer for motor A, you can simply increase it here. You understand? Let's increase now. I've increased now to like, let's say to 1 minute now. You understand? So this one too. Okay, let me just test this one. Yeah, let's operate it now again. You see now? Motor B is closed. So let's stop now. You will see the delay time will be more longer. You see now? I've stopped the system now, but motor A is still on based on the stopper timer that is attached with it. So this one now that will dictate to this one now when to finally stop. You see now, the system now is working perfectly. But let's say I start the system now. I start the system, this one is running and this one is running. I want to I want to change the system of this motor B, the delay time on how to operate, when to stop and when to operate. I can do that from this timer here. You understand? Then I will change the timing now. You can just change the timing here. You understand? Maybe I want it to operate more faster than how it used to be. I'll just change it here. Then to activate the setting that I just made now, I have to off and on motor B again. So let me off and on motor B. You see how it's going to operate now. You see now? You see how it's operating now? So it's this multipurpose timer that dictates to this motor how to operate, how to function. If I want it to be more faster, maybe the delay time is too delayed. I want it to be more faster. I can reduce the delay time here also. I will do the delay timer here. Then I will off and on again. Can you see the system? But motor A is still running. Motor A is still running. We continue running. So let's say I want to increase the delay timer. You understand? But to make the working timer to be more longer, I can just change it here also. Okay, now you see now the delay timer now will be more shorter than the working timer. Let me now off and on. You see now, I just set it for second. So the running timing now is higher than the delay timing. It's running now. This is delay. The delay is very short, just millisecond. I say just 2 milliseconds. You see it now. So this timing is what that dictates to motor B on how to operate. Why this one is just a stopping timing for motor A. This one is for motor B. Did you get how the system operates now? Then we now have another thing that we can also operate it automatically. Maybe I don't want to operate it using this manual stuff. So let's stop it now. Let's stop now. The system is stopped now. But this one, we wait until the stopper timer dictate to him to start working, to stop working. So it will now stop now. You see now. So now I want to operate using automatic. When you want to operate automatic, you are going to change this your selecting switch here. This one is a manual now. You just put it on auto. This auto now. You understand? This auto now. If you put it on auto now, then there is a terminal here. You see, there's a terminal here. These two terminal is where you are going to connect your signal that is coming from this machine in the field. This is where you are going to terminate it. We have some terminal here where you're going to terminate it. The label are there. So, but you are going. This is the two major one that you're going to be using. It's the one that will dictate to the system when to operate and when not to operate. So now, because there's no signal that is coming, I'm just going to use this loop to serve as the signal. So immediately I close these two terminal, it will still operate normally without starting. You see now, it can't hold because it's on auto. You understand? The system cannot hold. You see it. You see it. It cannot hold because it's on automatic. Let's put in manual now. You see now, this is different. This manual now. I'm operating manual. You see it's operating. So let's put on auto. It's on auto now. It cannot hold. But the delay time will still operate as it used to operate. So now let me now use this loop. I'm going to be using this loop now to to operate this automatic. You know it's on automatic now. So you can just, these two terminals, just loop it. You bridge it together. You see it now. You see it now. This auto now. So is the sensor now in the fridge that will be doing this closing and opening here. So when the sensor close, it will make the system running. And when the sensor open, it will make the system stop. But this delay time will still function as it used to be, depending on the timing here. Did you get it now? It is not stop now. You see now. So let's start again. You see it now? Stop. Assuming I don't want any delay on this, I don't want any delay. You can remove the delay. You can remove the delay. You can just remove the delay here. I don't want delay. I just want it to work immediately. No delay. I don't want delay. You understand? So we are now put your this thing. You see it's on stop now. It's stop. So we want to operate automatic now. You see now. No delay for motor B again. And when you stop, this one will only be on the stopper mode. This is on stopper mode. Did you get it now? So that's how the system operates. That's how the system operates. Let's try it again. Using automatic. It's on automatic already. You see it now? The two motors are running. You see now? That's how it operates. So the system says if motor A is not running, motor B will never come up. You understand? That's how the system operates. So I'm going to return it back to manual now, and we operate manually. So this manual now. We're operating manually now. So it will continue like this till Jesus come. But if I want to stop motor B, I can easily stop motor B from here. You understand? Then start it from here. Stop it from here. Start it from here. You understand? But if I want to stop the whole system, I will just stop motor A. Since it's motor A that dictates to motor B, I stop motor A. But this one will be on a stopper mode. Stopper delay mode. So if you continue running for some period of time. So depending on the setting, I can increase it, I can reduce it. So let me reduce it now. Let's just reduce it to like, let's say to 5 or 10 seconds. So it's running now. Let me stop. You see now. Let me reduce it again. So let's start. So yeah, let me stop. You see it now. And assuming I do not want a stopper mode to delay. So you just start, stop, start, stop. You see it now. Start, stop. So this one now is not having any stopper delay again. You understand? It's not having any stopper delay. Immediately you start the system, the two will start at the same time. And when you stop the